Today we're going to be talking about Newton's first law of motion. So these are video notes that you can write down or you can just pay attention to. All right, so force is when you push or pull on an object. The way that we measure force are in newtons. The symbol would be an N, but just like a couple other things that we've talked about, that N actually stands for kilograms times meters per second squared. So I know it's a lot of units all shoved into one, but just keep in mind that when we talk about Newton, we're talking about 1 kilogram times meter per second squared. So we know kilogram is for mass and meters per second squared is for acceleration, and we've already talked about that. So force can cause an object to change its motion. So if I push against a table, depending on how heavy that table is, I should be able to move that table. Or if I get hit by a car, I'm probably going to be moved. So it can be a push or a pull on an object. More than one force can act on an object at a time. So if I get on one end of a table and another student gets on the other end of a table and we push the table at the same time, whoever pushes the most is going to move the table in the opposite direction. So if we look at this box, you can see person 1 is applying a force of 4 newtons to the right, and then the second person is pushing the box with a force of 5 newtons to the left. That means the box is going to move to the left because the person is pushing harder with a greater force on the right. All right, so balanced forces mean that the box is not going to be moving. So if person 1 and person 2 are both pushing the box with 11 newtons, the net force is going to be 0 newtons, and the box is not going to move because they're pushing in opposite directions. Now, unbalanced forces mean that they're not equal on both sides and that they're going in opposite directions still. So let's say that we have 2 students on the left. One's pushing at a force of 6 newtons and the other is pushing at a force of 5 newtons, and they're both pushing towards the right. Well, that third person is on the right side of the box and they're only pushing with a force of 3 newtons to the left. That box is going to slide to the right because it has a total force of 11 newtons on the right and 3 newtons on the left, and we have to subtract. So 11 minus 3 is 8, and it's going 8 to the right. Now, Newton's first law says that an object will move at a constant velocity until a net force acts on it. So we can talk about a lot of different types of ways that forces can act on things like friction or gravity or air resistance. But you need to know that any type of force is going to act on an object that is moving. So an object will stay in motion unless acted on it by an outside force. An object will stay at rest unless acted on it by an outside force. All right, so I want you to pause your video and I want you to go outside and get like a soccer ball or a rock or any type of sports ball, and I want you to put it in the grass and I want you to kick it. Now, don't try to kick it all the way, to the next continent, but just kick it across your yard. And I want you to think about what is happening to that ball as it rolls across your yard. What is acting on it? Is there grass that's acting on it, which is making it slow down? Did it hit a tree? Did it hit concrete? What is making that object stop? Now, I want you to place a rock out in your yard and do not move it. And I want you to watch it for a little while. Did that rock ever move? The answer would be no, because nothing is acting on it. No forces are making that rock move. So both of those situations are Newton's law, first law of motion. And that first law of motion is called inertia. So inertia is a tendency of an object to resist change. So objects do not want to change. They want to keep doing what they're doing. Like you, if you're taking a nap, you want to keep taking a nap. You don't want to wake up. Or if you are playing and running around, you want to keep moving. So an object, inertia, is the tendency of the object to resist the change in motion. All right, so I want you to imagine you are riding in the car with your parent, and you have a cup of hot chocolate, okay? Now, there's no lid on your hot chocolate, and you're just riding down the road, but then all of a sudden, your parent slams on the brake. What is going to happen to that hot chocolate? It's going to fly out of your cup because there's nothing to stop the hot chocolate. It's just going to keep going. So the more mass that an object has, the more inertia it has. That's why we have to wear seatbelts. Because if you did not have on your seatbelt, that's why you could fly through a window. But if you have on your seatbelt, it stops you. There is a force that stops your inertia. So here is the experiment I want you to do. I want you to go outside, and I want you to get 2 different types of sports balls. So like a basketball and a soccer ball, or a tennis ball and a basketball, any sports balls. Now I want you to bounce them. I want you to hold them at chest high, and I want you to drop them and see how they both bounce. Then I want you to make a hypothesis, and what do you think would happen if you stacked the bigger ball underneath the smaller ball? So put the bigger ball on the bottom, the smaller ball on top, and I want you to drop it. What do you think is going to happen? And I want you to put this answer into Google Classroom below the video, okay? All right, what happened when you bounced the smaller ball on top of the bigger ball? Okay, experiment number 2. Get any type of cup and get any type of playing card. So it can be an Uno card or a Face 10, or it can be a deck of cards. It can even be like a piece of paper. That would be fine too. And a coin. Okay, now place your cup, place the card on top of your cup, and then the coin on top of your card. Then I want you to do that magic tablecloth trick where where that person pulls the tablecloth and all the dishes are made on the table. So your cup needs to be upside down, okay? Or no, it doesn't need to be right side up, my bad. It needs to be right side up, and I want you to pull the card, but try to make the coin land in the cup and not go flying off real quickly. So the explanation of this is that the coin has inertia. It wants to stay still, but you move the card. So it wants to stay in one place. And if you move the card quickly, the coin won't have to move. It'll just drop down the cup. But if you don't move it fast enough, that's an outside force that makes the cup move. It makes the coin move, and then the coin will not fall into the cup. So I want you to try the last part. It says, if you are brave, place the coin on your finger, the card on your finger and the coin on top of the cup, and try to flick the card out until the coin stays on your finger. So you're no longer working with the cup. You're just working with your card. So you have to keep your finger still and the card fast. And if you can do that, I want you to explain it to me in the Google Classroom that's with this video.